Okay, for this lesson, we're going to take a look at a review of converting between entire and mixed radicals. So this is basically what we should have covered in Math 10C. We know for square roots, cube roots, and other roots, all positive numbers have two square roots, one that is positive and one that is negative, because a positive times a positive makes a positive, a negative times a negative will still make that positive. The positive square root we call the principal square root, and that is just using the basic square root symbol. The square roots of a perfect square are rational numbers. So the square roots of 16 are both 4 and negative 4. But if I said this symbol with 16, then in this case, because there's nothing beside it, it's only looking for the principal square root, which is 4, the positive version. The square roots of non-perfect squares are irrational numbers. So the square roots of 17 are 17 and negative, or root 17 and negative root 17. We don't simplify it beyond there because we can't. When we're talking about cube roots, all numbers, positive and negative, can only have one possible cube root. So a negative times a negative times a negative is going to be a negative. Positive times a positive times a positive is going to be a positive. So there's only one possibility. It's only with the even indexes that we're going to have multiple possibilities. The cube roots of a perfect cube can be a rational number, so the cube root of 1000 is 10. The cube root of negative 27 is negative 3. The cube root of a non-perfect cube is an irrational number, so the cube root of 49 would still be cube root of 49 because we can't simplify it beyond there. So if I'm filling in the statements, the fourth roots of 16, well, if I take the fourth root of 16, that's going to be 2 or negative 2. But if it's asking for just this, which is the principal root, that would be just 2. The fifth root of negative 32 is negative 2. And if it's an odd number, it's only going to have one possibility anyways. It's only going to be negative 2. Now, it says evaluate without using a calculator. I'm not going to take your calculator away, so you can always have it to just verify whatever it is that you're doing. So if I said the square root of 64, most of you guys will know that that is 8. If I said the square root of negative 64, that's not possible. No number multiplied by itself, whether it's positive or negative, will make a negative number. So I can't take the square root of a negative. The cube root of negative 64 is going to be negative 4. The fifth root of 1 over 32 is the same as the fifth root of 1 over the fifth root of 32, which is the same as 1 over 2. The fourth root of negative 16, well, once again, it's an even index and a negative radicand. Can't do it. Not possible. If I multiply it an even number of times, it's always going to be positive. And when I get 10 and the cube root of 125, then I'm going to say 10. I can simplify the cube root of 125 down to just 5. And then because 10 was a coefficient, I'm going to multiply them just to get 50. When you go into the math functions on your calculator, you will find the x index, which you can use for any index that you need. So when I plug it into my calculator, if it wants the fifth root of 243, I should get 3. If it's the seventh root of negative 16,384, I get negative 4. And if it's the cube root of 125 over 216, remember that's the same as the cube root of 125 over the cube root of 216. You can do them individually, and you're going to get 5 over 6. Sometimes it will need to do it to the nearest tenth, the nearest hundredth, or whatever for irrational numbers, and then you just need to be able to plug them in the same way. The fifth root of 500 is approximately 3.47. The sixth root of 0.6 is approximately 0.92. And 2 over 5 times the fourth root of 100. You can put all this into your calculator bracket or use the fraction function on your calculator, 2 over 5. And the fourth root of 100. And that's going to give you approximately 1.26. Any radical with the root symbol, which we also call the radical sign here, is an example of a radical, obviously. When we look at a radical or an entire radical, it's made up of the three parts. There's the index, which means how many times the number would have to be multiplied by itself to get what's inside. There's a radicand, which is the number that we're reducing or whatever exists inside. And then there's a radical sign. This entire thing makes up a radical. Most of you guys already know this, but if an index is not written, it's a square root, and there's just an imaginary 2 there. When I'm combining radicals, and you can double check this in your calculator, if I multiply two radicals with the same index, I can just multiply the radicands. If I'm dividing two radicals with the same index, I can divide the radicands. I can't add them, and I can't subtract them. So if that's true, then if I take root 3 times root 5, does it equal root 15? Well, yeah, it's multiplied, and 3 times 5 is 15. This is true. If I take root 30 divided by root 10, is it root 3? Well, they both have the same index. I'm dividing, so I can just divide the radicands. 30 divided by 10 is 3, and this is true. If I take the square root of 16 plus 9, is it the same as the square root of 16 plus the square root of 9? No, it's not. If I took square root of 16 plus 9, that'd be square root of 25 equals square root of 16 is 4, square root of 9 is 3. 5 does not equal 7, so that is false. You can plug all these possibilities into your calculator to see to 5 decimal places what they equal. And if you do it properly, you should find that the square root of 96, 2 root 24, and 4 root 6 are all equal to 9.79796. What do you notice about all the answers? They are all equivalent or they are all the same. If the answer is all the same, then that means that they have to be equivalent numbers. So why are they equivalent? Well, we already said that if we divide or multiply radicands, it's the same as dividing or multiplying the radicals. So if I said that I had the square root of 96, then one of the factors, or one set of factors of 96 is 4 and 24, which means that it's the same as the square root of 4 times the square root of 24. The square root of 4 is just 2, because it's a perfect square, and I can multiply it by the square root of 24, and I have an equivalent form. If I did the same thing and pulled out the factors of 16 and 6, square root of 16 times the square root of 6, well, the square root of 16 is just 4, and the square root of 6. So they're all equivalent because they're just different forms of the multiplication of radicals. Square root of 96 is an entire radical because there is no coefficient. Two root 24 and 4 root 6 are mixed radicals because they do have a coefficient, which we can see here and here.